so there's a few sensitive areas in the brain, as you can imagine, that you don't want to skewer. Yeah. Blood vessels being the primary example there.
Oh, what's that you have there?
This is a cannula. So this is used for convection-enhanced delivery.
Into what areas?
So convection-enhanced delivery is the technique of infusing therapeutic agents into the brain. So it uses the natural convective currents of the brain and the pressure gradients from the cannula itself to push the molecules more uniformly and more deeply into the brain rather than a passive diffusion.
Oh my goodness, this is some serious brain surgery stuff. There's got to be some specific things about this. I assume that you want to keep the cannula super rigid, and tell me a little bit more about it.
Yeah, absolutely. So it's quite important that the rigidity is controlled during insertion, but after the cannula is in place, sometimes, for some cannulas, the rigid portion is removed and the cannula is made flexible. So this allows for longer term infusions, the tubing to be routed away from the wound site and pathogens from entering the brain.
Okay, so this is, obviously there's a lot of stuff to avoid. How do surgeons use this cannula in order to navigate to where it needs to get to?
Yeah, so it's a complicated process, as you can imagine. The cannula is placed using a neuro-navigation system to plan the trajectory. Yeah. So they use preoperative imaging to plan the target area of the brain, and then this neuro-navigation system allows them to see in real time where they are in relation to the entry point and the target that they're infusing into.
Holy moly. So what are some of the things that you're trying to avoid then if you're trying to place a cannula into somebody's brain, which just sounds crazy?
Yeah, so there's a few sensitive areas in the brain, as you can imagine, that you don't want to skewer. Yeah. Blood vessels being the primary example there. Fun fact, there's about 600 kilometers of blood vessels in the brain, and that equals about 2,000 Eiffel Towers stacked end to end. So lots to avoid.
Wow. Holy, that's amazing. And so is this something that we've worked on in the past? And tell me a little bit about your experience with these cannulas.
Yeah, so I've worked a little bit on cannulas here at Starfish and the guidance devices that guide those cannulas into the target regions of the brain. It's very rewarding work, but it's pretty challenging. As you can imagine, the scale of the device is the primary challenge. It's very, very small.
Awesome. Well, I'm sure people like him really appreciate that.
Yeah, absolutely.